Functions in Swift language are quite advanced, and there is something we could call functions programming, but in lessons here I will explain basics of functions in Swift, how to use them, and what kinds of functions we have in Swift. In general, if you would like to declare functions, which means block of reusable code, we use keyword func, name of the function, parentheses, where we placed parameters, and for this function there is just curly braces, there are curly braces, and inside some block of code. I will explain functions from the simplest one to the most advanced. This function takes no arguments, no parameters, the parentheses are empty, and it returns nothing. If it would return some value, we would place arrow and the data type, but for this very simple function, it takes no parameters and returns void, which means it returns nothing. And this is simplified way we can declare this function. Inside this function, it just print some output on console. As we can see, hello in function. This is this line here, and that's it. This is the simplest function you can find. As long as it doesn't return anything, there is no return type, just name, keyword, and empty parentheses here. Here we call the function, and here it's executed. The code inside the function is executed here. This part is only declaration. We describe here what kind of parameters the function takes and what is the return type and what is exactly inside the body of the function between curly braces here. Second step is function which takes some input parameters and it still prints something to console, but it takes parameters. So we can see keyword, simple function 2, this is the name of the function, and now we have name of the local variable. This is local variable with the data type, and the second one, there are two parameters taken by this function. First one is float data type and second one is double. We have names of the parameters, actually not variables, because they are just parameters. We can call them parameters. In fact, they are constants, but not to complicate the description, this parameter name float data type and second parameter name, and data type is after colon, as we can see. Name of parameter, colon, data type, comma, and next parameter. Return type, there is no return type, it's void, and curly brackets, curly braces where we place a block of code for our function. This function, it prints out some result on screen, float, and it prints the first parameter and second parameter. Because second is double, we print first one and after that second one. And here in this line we execute this function. We take it should print this value as a float, and it prints, and this value, this is double, and it prints double here. Next step, function taking input parameters and returning float data type. Returning some result, and the data type of this result is float. Keyword, name of the function, first parameter, second parameter, and it returns, this function returns float data type. There is some result, and the type of this result is float, and this arrow shows that there is some kind of returning data type. What this function does actually is it returns sum of two parameters, but because there are different data type, it converts first the second parameter from double data type into float, and then it adds this value to the first parameter, and it returns this value here. It prints nothing, but it returns the sum of the two parameters, converting first the second parameter from double to float. And here we execute this function. First number is float data type, second one is double, as we can see, because the precision is much higher. So this is converted first to float and added to the first parameter, and the result we can see here. It's not printed on console because it's just returned this value. We could print it obviously, but it is just returned. Point 4. Function taking input parameters and returning tuple. This time we return tuple here. A function takes parameters which are float and double, and it returns tuple, but first it obviously converts the first parameter into integer and second one as well, and we have this tuple which returned. It should give obviously 8 and 4 because we convert this only to integers. For this example, what we could do to make it more, easier to understand is we could give the name for first tuple value and second one, and here we can ask to show the value of the first one. It should be 8. We have 8. The second tuple value is s. I use names for tuple values here. The next one is s, and this is 4. We can use it or we don't need to use it, basically. It depends. Sometimes more description helps to understand something much easier. Point 5. Function taking input parameters but returning array. Keyword, name of the function. We have 3 parameters here, name of parameter, colon, and data type. But now we expect array which has items which are all float data type. So what this function does, it just takes all the parameters and places them straight away into simple array. But before that, for the second and third parameter, it needs to convert the values of parameters into float data type. And we call this function here, and this is converted. This is result of how this function works. It creates an array. Point 6. Function taking input array returning integer. This simple function takes just array built of integers and return one number, which is integer data type. Inside we have simple loop which takes values from the array, from parameter array, and adds all the values together and returns the sum, the total sum of all added numbers inside the array. Here we declare this array built of integers and call the function to execute it, and it just adds all numbers together. Function with external and local names. Sometimes there is longer list of function parameters, and it's much better to give them specific names we can use when we call the function. For instance, this example of the function which uses external and local names. This local name for parameter, we use it inside the body of the function. This one, as we can see, this function takes 3 parameters, all double, and this function returns one double. This function actually calculates the volume of some cube. So this is internal local name, h, w, h, and depth. And this function returns just multiplication of all the values. However, before the local name, we use another name, which we call external name. And this name here, here, and here, we will use calling the function somewhere down the code. However, for simplification, we can use it here. We use width, this is this one, height, and depth. It's easier to understand what is what, actually, when we call the function. Sometimes we would like to keep the name because of meaning of the name in the more complicated value function and not to repeat it. So to do it, we can use this hash symbol, and it means that this name for the parameter is both local and external. So we can use it locally and externally. Actually, if I change it into $2, I get good result as well. Point 8, pass value by reference. So far we use parameters which are used locally, and we cannot modify external variable outside of the function. But if we would like to do it, we need to use keyword inout. It means we want to reach external variable, and it can be modified this way. So now we can see we use some v, external variable, inout. It means external variable. It's not name, it's about just variable existing outside of the function, and we want to modify it somehow. To be able to reach some variable outside of the function body of function, we need to use this keyword inout. And here is example. We have variable delta, which is integer, and it's 5, and this function, actually what it does is just add increment parameter, which is external variable, by 1. So modify external, we try to modify this variable, and if we use this kind of function which takes external variable, we need to add this ampersand symbol before the variable parameter name in parentheses here. This way, this function will modify this variable as described in body of function. And if we try to print it, we have delta variable, and it's increased by 1. It was 5, now it's 6. This inout and ampersand is the only way we can do it if the variable exists outside of the function. Point 9, nested functions. Sometimes to avoid collisions with functions names, we have to declare some function inside other function. This function is printout, the name is printout, and it's so big, but inside it does something with parameter of the, let's say, parent function, which is array here float. It takes the array is taken by another function declared inside, and it returns float. In float, what we have is what it does actually, it calculates average and sum, and the first returns tuple. The first part of tuple, it's here. The first part is average value from the array, and second part of the tuple is sum of all items in array. So basically, to return it, this function inside, this nested function, calculate the tuple where the first value is average and the second one is sum of all items in array, taken by, let's call it, parent function. And what this function does, this printout, it just uses this function here to print the tuple. And as we can see, when we declare array floats here, we call this function, this one, which has nested function get average sum, and result is here nested tuple average and sum. This is average value and this is sum of all items. obviously inside we have more nested functions, not only one. There can be more, and it's much better to use this kind of approach inside the bigger function if basically the functions if this function inside this nested function is useful only in the body of the main function. Point 10, default values for parameters. Let's say there we would like to describe some default value for parameters for some reason. What is the reason? I will explain in a moment. And why we assign some default values. We do it if we don't know if we will need one parameter or two parameters or maybe no parameters when we call the function. If we define default value for parameter, it means the name for this default parameter will be external automatically, and we don't need to use this parameter. We can omit this parameter, and if it's not used in function call, it will be the value for this parameter will be default one, which is defined here, which means if we call this function R area because of rectangle area, and we have two parameters here, both are default, have default values, it means that when we call the function without any parameters, the function assumes that we want to use default values. So basically this empty set of parameters here means use width 2 and use height 3, which means if it calculates area, it will be 6. No sites, I mean no parameters inside parameters list in parentheses, which means volume area is 6. And now we call only width, and we assign value 3, but there is no height here, which means because height has default value, height will be assumed to be 3. So 3 times 3, because we assume height is 3 because it's not called here, 3 times 3, it means the area will be 9. So if we are not sure if we will need some parameter, we can set default value for this parameter, and automatically the name for this parameter is the both local and external name.